Hi, I have built this multi-agent orchestration system. So I would like to show you how does it work and how the code base of it look like. So this multi-agent system is basically having a master router agent and having five other individual agents that perform individual tasks depending on the user input. And I will show it to you how does it work. So here we have let's look at the architecture. So here we have a master router agent, and here we have five individual agents. So we have search, intent, instruction, conversation, and memory. So these agents perform specific tasks. You can see it here, and after that we perform a response synthesis. So basically we put together all the responses from all the agents, and then we compile that response and return to the user as a final output. So if I talk about the code base, then it is organized as agents, then API, and then some utils and test cases. So in agents, we have a master router agent that coordinates to all the other agents, and then we have individual agents like this. So and in API we have a main.py, so it runs a fast API app, and it exposes an query endpoint that expose the functionality of all the agents, so that anyone can just make a query and then get the response. And after that I also implemented caching using Redis, so that we don't have to ping those agents again and again. Just in case if there is a duplicate query, then we can just pull it from the Redis instance and just return to the user. Also, I've implemented circuit breakers, so just in case uh, agent fail to create the response or perform their service, then in that case the circuit breaker will kick in, and it will stop the service for a couple of seconds, and then it will resume it after some time. It's just for the sake of prototype, it's not very complex. And so after that I will show it to you how does it work. So here I made couple of queries here, but I will make a new one. So you can see here, this is a query. I am making a query to this query endpoint, and it is, you can see it is running on localhost 6000, and this is the query I am making. You can see I love pizza, so how to make one. And so if I just run it, then you will see here it will create the response by taking the responses, individual responses from all the other agents. So you can see here, here it will list all the agents. So here it is the search agent, then it is the intent agent, then instruction agent, and then conversation agent, and then memory agent. So and it is also explaining how does those what is the response of all those agents. And as the final output, you can see here it is the final output of the that response synthesis that I mentioned some couple of minutes ago. So you can see this is the final output. And if I have to show you, then let's look at logs. So it took it around 4.21 seconds. So it varies. I tried to run it couple of times, so it varies. I mean, how much time does it take? And if I talk about the caching, then you will see here, just a second. Okay, so let me show you. So if I run this query again, you can see here this query is the same as we did before. So if I just run this again, then what will happen is it will be very quick. And the reason for it is the caching. We implemented caching here. So let me show you. Here you can see here is a caching log, and you can see it hit 12 times and it missed 11 times. So that is what I did. That is what was the part of the testing. So, and also you can see here that let me just increase brightness. Okay. Okay, so here also if I just run it again just to show you how does it hit the cache, then if I go back to it, then you can see I hit 13 times and missed 11 times. So it is caching each query, and in case of there is a same query, then it will not hit then it will not use agents. It will basically hit this Redis instance that I am running locally. You can see it here, and just a second. Okay, so here it is, and let me show you the caching code. So not just caching, let me show you all the code. So here we have this master router. I used LangGraph for it, for this prototype, and it is using this LLM for the purpose of an LLM, and it is using Tavily. I don't know how to pronounce it, but Tavily or whatever, to make search, to make online search, so that it can get the information from the internet. And here you can see it is this is a search agent implemented using LangGraph. This is memory agent, and this one is I've already opened it. Okay, so this one is intent, and this one is instruction agent, and this one is conversation agent. So all these agents perform parallelly. This Let me show you one thing. So you can see it here. I am creating a supervisor using LLM, using LangGraph. So LangGraph has a built-in functionality for executing the LLMs parallelly. So I didn't have to execute that logic explicitly. So here, okay, yeah. So yeah, that was all. And just for the detailed response, we can read it out here. It can search anything from the internet, and it can present it the way we want it. Also, we don't necessarily need these things other than this final output. So we don't need these things. I have just logged these just to show that how does it work, and what are the individual responses of uh, each agent. Also, you can see here it collects some links, so we can go to these links, and we can find more details about how to make a pizza. I'm not going to make a pizza. So yep, that was all. And also I've implemented test. So just in case if I have to run test here, so let me run test. Okay, so all the tests are passed. So these are the 5 basic tests. They are not very complex, just a basic test to implement to test the logic we have implemented using LangGraph. And circuit if I show you circuit breaker, so instead of creating in this file, I've just implemented here in the main.py. Okay, so I'm using this pi breaker to implement circuit breakers. So, and here you can see I'm wrapping this whole agentic logic into in this breaker, so that whenever there is an exception, it will and it will see exception for 3 times. So if there are errors 3 times, then it will wait for 10 seconds and then it will resume. So this is how my basic circuit breaker will work, and I've also implemented caching. And yep, so this is multi-agent orchestration system by Ajit. Thanks.